Here we get to begin the second video for section 3.4, and where we left off was example number 8. Example number 8, we have the sine of alpha is 4/5, and looking at the information, even though it doesn't say so, it says pi over 2 is less than alpha is less than pi. I know that's in quadrant 2. Cosine of beta is equal to 2/5, and I know that is in quadrant 1 because beta falls somewhere between 0 and pi over 2. So what I need are my triangles for each one of these. I'm going to have one triangle that has alpha, the other triangle has beta. Now if sine of alpha is 4/5, that'd be a 4 there, a 5 there, and a 3 there. If the cosine of beta is 2/5, I have a 2, a 5, and a square root of 21. And then what we are asked to do is to find the cosine of alpha minus beta. So that would be cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. That is just simply using the identity. Okay. Now, in quadrant 2, I need to be very careful with the eigen's. So cosine of alpha would be 3/5, but since it's in quadrant 2, it has to be negative 3/5. Cosine of beta, being in quadrant 1, is everything's positive, so that would be 2/5. Sine of alpha, second quadrant, sine is positive, so sine of alpha would be 4/5. And the sine of beta, quadrant 1, everything's positive, sine of beta is root 21 over 5. Simplifying, we get negative 6/25 plus 4 root 21 over 25, and combining this into one fraction, 4 root 21 minus 6 all over 25. Example number 9, which completes this particular group. Cosine of alpha is 1/3. And according to the additional information, we are in quadrant 1. Sine of beta is negative 1/2, and according to the information, beta falls between negative pi over 2 and 0. So that's the fourth quadrant. The appropriate triangles need to be drawn. So the cosine of alpha is 1/3, so this would be 2 root 2 using the Pythagorean theorem. And then here, if the sine of beta is 1/2, that would be a 1, a 2, and the square root of 3. Now realize we could have actually found the angle, but just for consistency, I'm putting it into the triangle. And what we're asked to find is the tangent of alpha plus beta, which is the tangent of alpha plus the tangent of beta all over 1 minus tangent alpha tangent beta. Okay, the tangent of alpha in quadrant 1 is positive, so the tangent would be 2 root 2 over 1, or 2 root 2. The tangent of beta in fourth quadrant, well, it's negative, first off, and 1 over root 3 becomes root 3 over 3. Then 1 minus those same values being multiplied together. So it's just a matter of manipulating this appropriately. First off, I'm going to get this as a common denominator, and that common denominator would be 3. So this becomes 6 root 2 minus root 3 over 3. And the denominator, same thing. Well, first thing I'm going to do is to actually multiply these together. So it's 1 minus 2 root 6 over 3. Okay, now I need to make the denominator have a common denominator, which will happen to be 3 as well, which is very nice because now the 3's will cancel. Now it'll be 3 minus 2 root 6. And so the 3's cancel each other out, and so we're left with 6 root 2 minus root 3 over 3 minus 2 root 6. And normally we don't like this, but if this has an addition or a subtraction, I will let it pass, and so this would be the final answer. Example number 10. Sine of theta is equal to 1/4. And theta is in quadrant 2. Find the exact value of the sine of theta minus pi over 3. Okay, well, I'm going to draw my triangle here, and there's my theta. Sine of theta being 1/4, I know that's a 1, that's a 4, and this would be the square root of 15 using the Pythagorean theorem. And so now the sine of theta minus pi over 3 is equal to the sine of theta times the cosine of pi over 3 minus the cosine of theta sine of pi over 3. Okay, sine of theta being in quadrant 2 is positive. Sine of theta is 1/4. Cosine of pi over 3. Well, cosine of pi over 3 is 1/2. Cosine of theta, well, being in quadrant number 2, that means it's going to be negative, and that would be root 15 over 4 times the sine of pi over 3, which is root 3 over 2. And then it's just algebraic manipulation from this point forward. 1/8 plus, okay, root 45 actually equals 3 root 5. Once you simplify that in its simplest form, we have our common denominator of 8, and so the final answer is 1 plus 3 root 5 all over 8. Example number 11. We are told f equals sine, g equals cosine, h equals tangent. We have some points. For example, the point is x root 3, and that lies on the circle x squared plus y squared equals 4. So just plugging in what we know, x squared plus 3 equals 4, x squared equals 1, so x would equal 1. We also have the point 1/4 y, and it lies on the circle x squared plus y squared equals 1. And so plugging in what we know, 1/4 squared is 1/16 plus y squared equals 1. So y squared equals 15/16. So y would equal square root of 15 over 4, taking the square root of both sides. And what we're asked to do is find f of alpha plus beta. But f is sine. So what we are asking is, what is the sine of alpha plus beta? This is the alpha angle, this is the beta. It's one thing I failed to read in the book or in the problem, and therefore I need to go back and find that. But finally, we are there, and so I know that this is equal to the sine of alpha cosine of beta plus sine of beta cosine of alpha. So I just need to draw some pictures here. Here's alpha, and I know my point is 1 root 3. So if I've got 1 root 3, and by the formula I know that my hypotenuse is 4. Or we can calculate that using the Pythagorean theorem. Likewise, we can do this one, and beta will equal root 15 over 4. So this is 1/4. This is root 15 over 4, and this is 1. And so sine of alpha, okay, this is first quadrant, this is first quadrant, so we don't need to worry about any of the seconds. Sine of alpha is root 3 over 4. Cosine of beta is 1/4 over 1. Sine of beta is root 15 over 4 over 1. And cosine of alpha would be 1/4. And so we just need to do some simplifying here. This becomes root 3 over 16 plus root 15 over 16, and combining them all into one compound fraction, root 3 plus root 15 all over 16.